early days of computer programming, there was no terminal, like there's no screen. How do you make your program do something? It's literally by changing the way the thing is wired up. Like you're changing wires to run current through this path versus that path, and it goes through a set of magnetic relays. What's a magnetic relay? A magnetic relay it's a switch that turns on and off when you put power to it. So you put power to it, and it turns on the electromagnet that's in the switch, and it causes the contacts to close. And so you're putting power to one place, and it puts power to another place, and so forth. And so I think, well, I'm not sure which computer they were actually working on, but it was like, this program is not doing what it's supposed to do. And so it's like, well, how come it's not doing what it's supposed to do? We must have it wired wrong. They checked the wiring, the wiring's right. It's just not doing what it's supposed to do. And so they actually went to where they're looking like at the magnetic relays to make sure they're opening and closing. And one of them, the power was getting to the relay, but it couldn't close because there was a moth that had gotten between the contacts. So even though it was getting the signal to complete the circuit, it couldn't complete the circuit because there was a bug in the program. That's where the term comes from. So today we call it debugging, but it just means that's a short way to say we got to get rid of the errors. And really to understand kind of the process of debugging at a higher level, we got to understand there are three fundamentally different kinds of bugs that we have to deal with. And we treat them both differently. We treat all three of them differently. So the first one is a syntax error. So there's three kinds of errors that we have. Syntax error. A syntax error is something that is so bad that the Visual Basic interpreter, that piece of software that looks at what you've written in Visual Basic and says, I'm going to figure out what you mean by that. It looks at what you've written and goes, I have no idea what you're talking about. It just looks at it and says, I can't work with this. Bring me someone who can bring me something better to work with. And so let me go ahead and just kind of open up. I'm not sure I just pressed, but apparently it was not Alt F11. So I'm going to get rid of that sheet and try that again. Oh, it was Windows F11. Okay, so here's process products. And that's one of the nice things about our little Visual Basic interpreter is that when you have a syntax error, it's going to show you the line that has the error on it. It's going to say, look, I couldn't understand this. I don't know what you're doing here. What's wrong? What is syntactically wrong with it? It sees this red line and goes, I don't know what you're talking about. Anyone see the problem? Like the beginning of a do, so do and loop, do until products.cells.row, or products.cells, whatever row is 2.1 value equals a 0 length string. This is a normal loop. What's wrong? Yeah, I spelled until incorrectly. I spelled it unitl. So spell that correctly, and the error goes away. So syntax errors, you just have to get rid of them. There's nothing else you can do because the code can't even run when there's a syntax error. Now, will every syntax error show a red line? And the answer is no. Like, it'll show the line that has the error. So, like, what if I don't have the keyword loop in here? Like, it's just gone. It doesn't know where to show that. It doesn't know where you mean to put loop. It doesn't know, and there's nothing even to put red because there's nothing wrong. It's just not complete. So you can have syntax errors that the editor can't show you because there's just nothing to highlight there. But without that loop, if I try to run this, it's not even going to run. So can't compile do without a loop. And put it back in there. What error did it give me if I had until spelt wrong? Same thing, compile error, and then tells us a syntax error. This doesn't like it. Okay. So that's the first category. And the nice thing about this one is that the compiler is going to tell you something. Like it's going to say, like even when it was missing the loop, it's like at least, it highlights this part and says, I got here, it says do without loop. That's a pretty good error message. That really is what I'm missing here. And why did I highlight this? Why did I highlight end sub? Is it saying I got to this and I was expecting something else before I got here? What was I expecting before I got here? Loop. So it's going to do a pretty good job of helping you track down where the error is, even if there's nothing red for you to be able to see. Put loop in here. Sometimes though, by the way, the errors are not that helpful. Let me just put here, if x, or if row equals 10. Is this a syntax error? Yeah, what am I expecting to have if I have an if then? Well, you got to have something for the then. Well, you know, I've got to have, or like end if. I expect to have an end if in there. But I just kind of want to point this error out because this is something about the way that like compile time errors happen. That's a confusing error message. Why is that a confusing error message? Loop without do. You look at that and you say, what do you mean there's no do? The do is there. Right? The do is there. There's a do, there's a loop, that should be fine. Why does it say loop without do? So someone who's writing error messages goes, oh, you know what, this is really going to mess them up. We should give them this one. This will be great. Yeah, just make it say loop without do. It has nothing to do with the do or the loop. Yeah. Yeah, it's because, listen, you can put a do loop inside an if statement, or you can put an if statement inside a do loop. So you can put like one inside the other, but you don't get to kind of put them halfway in. It's got to be all in or all out. And so it's reading along here and it's going, hey, this looks great. Dim, I know it. Row, perfect. Do, we got a do loop, wonderful. Debug, whatever that means. We're going along. It gets to here and it goes, great, we're starting an if statement. And then it gets to this and it says, you have a loop inside this if statement that does not have a corresponding do. Like, if you have a loop in here, you've got to have a do on the inside of this if statement. So unfortunately, sometimes the error messages can be really misleading because you look at it and you go, what do you mean? The do is right there. So sometimes the error messages are helpful, sometimes not. That's the first type. Syntax error, you just got to get rid of it. Second type of error is a runtime error. I want to talk about that third. The third type of error is called a logic error. Logic errors, like syntax errors, you just have to get rid of. But the problem with a logic error is that as far as the interpreter is concerned, a logic error is no error at all. Like you have given it a bunch of things to do. The interpreter looks at it and says, I know exactly what you've asked me to do. I'm going to go ahead and do it. But it gives you output that you're not expecting. So in a logic error, the code runs just fine, but it produces unexpected results. And what that means is you told the computer to do something different than you thought you told it to do. So in a logic error, the computer understands what you said. You just don't realize what you said to it. And it's kind of there's kind of a subtle shift here that is really helpful when you're trying to track these down. They can be they are the most difficult ones to track down because you get no help from the interpreter. You get no help as to where the problem might be. But here's one thing that will be a little bit helpful, and that is when you're looking at a logic error, the tendency is to say, why isn't it doing what I told it to do? And like only very, very rarely is it not doing what you told it to do. It's almost always doing exactly what you told it to do. So what's the question that you should be asking instead of why isn't it doing what I told it to do? That's the question that will lead you to frustration. You should be asking, what did I tell it to do? Like, I told it to do something different than I thought. Where did I go wrong? It's like, it's kind of it's a subtle shift. I'm trying to figure out where did I tell it to do that? And that's, at least for in my mind, that's a little bit helpful. Okay, so syntax errors, logic errors, you just have to get rid of them. Logic errors are tough because you don't get any help from the system telling you where it is. And that's why we have a whole set of tools to track those down. That's what today's lesson is about. The other thing today's lesson is about is handling runtime errors. Now, a runtime error is an error that is, it's syntactically valid. What you've typed, the syntax is perfect, but when it actually goes to execute it, it's unable to accomplish what you told it to do. Here's an example. Let's suppose that like the first thing, starting off when I run process products, first thing what I want to do is make sure that the products page is active. So sheets, it's called products, products.select. Okay, there's no red line here. This is syntactically, this is just fine. And yet when I go to run this, it's going to give me a runtime error. So this is an error that happened after everything compiled, loaded into memory, we started running it, and now I can't accomplish this. Now, runtime errors, you get a lot of help tracking these down because you'll hit debug and it will show you the line that it failed on. Like I got to right here and I couldn't do this. And what was the error message? I'm gonna hit play again to see the error message. What was the error message? Subscript out of range. That's not a great error message in this case. But what's the problem? There is no sheet named prod.cs. There's no sheet named that. Syntactically, it's perfect. Sheets, it goes, yeah, that's the name of collections of the worksheets in the active workbook. Opening parenthesis, just what I expected. Oh, you've got a string literal in here. Perfect. It's a bunch of characters in there. That's all syntactically valid. In fact, at compile time, could the interpreter go, hey, sorry, you're not going to be able to run this. There's no sheet called prodcuts. I should say that as something I can pronounce. Prodcuts. There's no sheet called prodcuts. No. Like, it's okay for that sheet not to exist when this thing compiles because there may be something else happens. Like, for all we know, for all the interpreter knows, the user is going to create that sheet before they press play on whatever runs this. So it can't possibly tell you that it's not going to work. And so it goes, yeah, I'm totally going to try to run that. But when it tries to do it, it can't do it. And it's usually, well, it's often because you've got something spelled differently, doesn't exist that you expect it to exist and so forth. So runtime errors, we have two options for runtime errors. Okay, syntax errors, logic errors, our only option is to get rid of them. Runtime errors, we have two options. One is to get rid of it, like write our code so that the error just simply doesn't happen. But the second one is to trap the error. So our second one is say, hey, let the error happen. And when it happens, before you stop the program, we'll say, hey, listen, if there is an error, if there is a runtime error, go do something different. That's called an error trap. And you might think, why would you ever do that? Shouldn't you just get rid of them? And the answer is sometimes you can't entirely get rid of them. So sometimes it's like, yeah, that's going to happen, based on something. For example, like if I try to run a web query and my network connection is off, there's no way in VBA for me to say, sorry, there's no there's no web connection. Like well, there might be. I know of no way to be able to say, let's check the web, let's check the internet connection without doing something that would fail, that would cause a runtime error by doing it. And so what we'll do is we'll say, listen, all right, just try to fetch the web query. And if it comes back and says there's no network access, then say, okay, great. If there's no network access, then we'll handle it in this way. And so that is one of the reasons that we'll write an error trap. The other reason that we might write an error trap is we can say, yeah, we could prevent this from happening, but it's really expensive for us to figure out if the error is going to happen. Like computationally, it would take us a lot of effort to figure out, is the error going to happen? And it may be that we got to check like often, like we're doing some process and 20 or 30 times a second, we do a process that could have an error. And if it takes a second to figure out if the error is going to happen, that's really going to slow the process down. What might normally happen 20 times in a second is now going to take 20 seconds because we're checking to see if it's going to fail. And so you might say, you know what, just let it fail and trap it, and then we know what to do with it if it fails. So it may be that it's impossible to know if it's going to fail, or it may be that it's just like computationally difficult for us to know if it's going to fail. So just let it fail, and if it does, we'll do something different. And so that's what's called an error trap. Let's deal with the error traps first, and then we'll look at the so for handling runtime errors, and then we'll look at the set of debugging tools for helping us to track down logic errors. Okay, so I'm going to get rid of my little error here. And what do we got going on here? So this is process products. All right, let's just look at the data that we're dealing with here. So we've got like 600 or something different products that were from some outdoors site that was around in the early 2000s, where I copied this data from their website. I think they're long since gone out of business. But what is this? So we've got something here called Junior Swim Fins. It fits shoes 3 to 5, and they cost $4.99. and it's in the outdoor like department. I don't know, but this is like information about one product. Now, ultimately, we're going to use the same set of data when we start making complex dialog boxes, or also called user forms. So we can say, listen, instead of having to edit this data right here on this row, just bring up a box that has all the data in there for us to be able to work on it, and put some data validation on there, and maybe some drop downs to be able to choose from things, and maybe some check boxes to check things off and so forth. But one of the things that will be nice to us for us is if we look up here in column C, there's department. And so there's only 4 different departments: hunting, outdoor, apparel, and general, I think are the 4 departments that we have here. And so I'd like to be able to have those as a list somewhere so that I can easily put some kind of data validation on. Same thing for manufacturers. It's a limited set of manufacturers. I'd like to be able to have a list, an individual list built. So that's what we're going to do right now. So, we might start off by creating a sheet just to maintain these lists, but I would like my code to do that for me. So let's go ahead and say, that's our task. We're going to want to run through all of these and just build the unique set of departments. So that's what we're after here. Okay, so I think right now this is probably working out. I've corrected the syntax error. Yeah, so it's just running through and printing off the 600 or so products that we have here, or I guess it's 861. That's probably the row number. So now here's what I'd like to do is I would like to bring some code in here that will build me the set of unique departments in my set of products. So right after we do the printing, let's just go ahead and come in here and say, let's make a unique list of products. All right, so we're going to want a sheet called lists. And we're going to put all of our lists on this sheet. We're going to have a list of products, a list of categories, a list of vendors. Maybe there'll be some other lists that we put on here. A list of promotions that we're maybe dealing with. So let's just say, let's find out like the column that we're going to work with. So let me give myself a variable here called call. Whoops, dim call as integer. And let me do dim found cell as integer. So listen, if I run this and my list of products already exists, I don't want to make a new list. I don't want to make a new column for products. So let's start off by just finding out if we already have, like on our list sheet, we'll put the name of the list on the first row. I just want to find if we've already got this one, called department. I'm sorry, I don't want a list of products. I want a list of departments. All right. So here's what I'm going to say. I'm going to say set found, not found cell as integer. Found cell should be a range. So found cell is going to, I'm going to use that to hold the cell that it found. Set found cell equal to worksheets and the worksheet called lists dot rows number 1 dot find, and then I'm looking for whatever is like the heading here. So the heading is department. So I'm finding the text called department on this row. And I'll put 3, I'm going to skip the next 3 arguments and then just put here XL whole. That says I'm looking for a match of the contents of the whole cell. So I want to see where it says department on row number 1. Now, what is the problem with the code that I've written so far? There is no worksheet called lists. And so this is going to give me a runtime. Syntactically, it's just fine, but it's going to give me a runtime error. So I'll run this subscript out of range. There it is. Subscript, let me give you some sense as to why they say subscript out of range. If I was to say sheets or worksheets sub1 dot name maybe because I'm in break mode, that should be okay. Oh, not, it should be name, N-A-M-E. It's called products. This is called a subscript. In fact, why do we call it a subscript? Because what we really want to do is we want to say worksheets, and we really wish we could put a subscript next to it, a little one that's down a little bit, saying, you know, which worksheet am I talking about? I'm talking about worksheet number 1. But you can't just do a subscript in program editing environments. And so we put it in parentheses to say, we'd make it a subscript if we could, but we can't. So in parentheses, we call it a subscript. So that number that's inside the parentheses is referred to as a subscript. That's why it's referred to as a subscript. It's like if we're writing it by hand, we'd like to say worksheets and put a little lowercase or a little small 1 next to the word worksheets. And so if I told it to do a sheet that didn't exist, like sheet number 10, that message makes perfect sense. The subscript is out of range. What's the valid range for this subscript? Yeah, 1 and 2, that's it. Anything out of that is a subscript out of range. And somehow it's the same problem when I try to find one that doesn't exist. It's the same problem. You're trying to refer to a sheet that doesn't exist. Now, it's not a subscript involved, it's a name. But still they give us the same error. So there's some intuition as to why it says subscript, not subscript out of range. All right, but that is a runtime error. Now, one approach that I could do here is to say, well, let me write a function that just before I try to look for a worksheet called lists, let's go and check to see if that exists. And we're going to do that today. Like, we're going to see both solutions. 1, get rid of it, don't let the error happen. 2, let it happen and then fix it. In fact, let's prevent it from happening first. And then we'll come back and see what the error trap looks like. So there is no way just to ask Excel, does a worksheet exist? But fortunately, we're like VBA capable. And so we're going to make a function to do that for us. So function, sheet exists. We're going to give it a sheet name as a string. You give it you give us and this will be as Boolean, because return true or false. So you give us the name of a sheet, you give this function the name of the sheet, it'll tell you if the sheet exists or not. How are we going to tell if the sheet exists? Any thoughts? What could we do? Yeah, go ahead. Oh, okay, so we could build an error trap down here. The whole point was to do this without an error trap. So that would totally work. Yeah, that would work and be a reasonable way to do it. So how do we do it without triggering an error? Yep. Yeah, just iterate across all the sheets and see if the name matches. The names of anyone match, not a problem. We've done stuff similar to this before. Let's make another variable here. Dim sht, that's short for sheet, as an object. What kind of object? A worksheet object. Worksheet as a worksheet. For each SHT in worksheets. In fact, maybe I'll say this workbook.worksheets. Otherwise, it would assume the active workbook. I'm not sure that's a good assumption. So this workbook.worksheets for each SHT in this workbook. Oh, I think I hit a backtick there on the end. Next, and then I could just do here debug.print. sht.name, and that would just print off the names of my worksheets. Let me just go ahead and I'll just run this from the immediate window. And I'll just say sheet exists, argument not optional. Oh, I got to give it a name. Hi there. And it's just, at this point, it is just printed the names. But what I want to do is I want to say if that sheet name is equal to, I want to do a I want to do a case insensitive comparison. I don't care what the case of the sheet, I don't care what the case of the sheet name is. I don't care what the case they pass us in. So I want to do a case insensitive comparison. There's a couple ways to do it. The way that we can do it with what we know already is just to look at the lowercase version of each one. If the lowercase version of the sheet name is equal to the lowercase version of whatever got passed in, then what do I want to do? I want to set my, that means the sheet exists. So set my return value equal to true, set the name of the function equal to true, and then I'm done. There is no reason to keep looking. Am I going to find another sheet with the same name? No, I can't have two sheets with the same name. There's no way I could find another sheet with the same name. There's no reason to keep looking. Even if I did, what would I do? Make it extra true? It's double true? It's capital true? So once I found the condition, I'm done. So now this should, if I print the results of this, this should print false because there is no sheet name. If I spelled sheet name right, there is no sheet named hi. That prints false. But if I look for promos, then it tells me true. Yeah, promos exist, products exist, anything else doesn't exist. So now, with that in place, I can now say, listen, before I try to bind found cell onto that, you can actually find the cell on a sheet that doesn't exist, let's check to see if it exists. So I'm going to come up just before this, before I do this, and I'm going to say if sheet exists. Whoops, if sheet exists, and then I'm looking for lists. And in fact, what I really want to do is I want to do something if the sheet doesn't exist. So how do I change this? How do I make this execute, the code inside this execute if the sheet doesn't exist? Do I have to write another function, not exist, sheet not exists? No, I can reverse this with not. So sheet exists will be true, but I only want to execute when sheet exists is false. So I will say, so this whole condition will be true when sheet exists is false. So if the sheet doesn't exist, it'll return false. The not will flip it to true, and I'll execute the code. So now I should be able to say, so if not sheet exists list, what I want to do, I want to make the sheet. Just make the sheet. Worksheets.add. Worksheets.add will create a new worksheet. And what will it do? It will return a reference to the sheet that it just created. So this is going to look a little bit weird. So worksheet.add is a method of the worksheets class that will add a worksheet and return a reference to the sheet that it just created. Now, what we've done in the past is we've said something like a variable called sheet. Sheet equals worksheets.add. And we've captured the reference to that. And then we could say the name of that variable, change the properties. But the only thing I want to change is the name. And then I'm done here. And so this will evaluate to the sheet that just got created. And I want to modify the name property of it. And so I'll change it to list. It's a little bit kind of a weird construction here. But it's in this case, it's kind of handy. I only want to deal with one of the properties. So I don't have to worry about capturing a reference to it. Just use the reference that comes back from the one time that it's available here and set the name to list. Now I should be able to set the found cell to this. Let me go ahead and put stop right here. When you run to that point and stop, we'll see what we get. Yeah, look, it's created a sheet. It's actually named it lists down here, and it set the found cell to it. Now, when I try to do the find, if it is successful, this will return a reference to the cell that it found it on. And so found cell will be bound on to the cell that it founded, where it found the cell that it identified. But there is no cell in that first row that has the value list in it, and so it doesn't find it. And so what it returns instead is it returns a special object. The object is called nothing. So it's a little bit weird here, but nothing is an object. Nothing is something. It is something. It's an object that has no methods and no properties. It's just like a blank object. But I can check to see if it returned that object to know if it found it or not. So here I'll say set found cell equal to that. And now I can say if found cell is nothing. So I use the is operator to, that will let me know if two objects are the same object. So found cell is nothing. If found cell is bound on to nothing, found cell is nothing, or is, yeah, found cell is nothing is true. Otherwise, it's false. So if found cell is nothing, it did not find that value. So all I want to do is now like create a value. I'm going to like now say, give me a place to start building this list. So I'm going to put the word department in row 1. Where should I put it? Because there could be 3 or 4 different lists in here, and I want to be able to kind of put it at the end. Or, yeah, I better put it at the end because I think I'm going to rely on once that list goes into a column, I'm going to be relying on that column sticking around. So it might be easier just to insert a new column row and put it a new column 1 and put it there. But let's go ahead and find the end and put it on the end. Whew. Well, we're doing a lot of great things in this example. Okay, so, oh yeah, I already made a variable for this, so call. So let's figure out what column we're going to do it. So if found cell is nothing, we need to add a column that has that value. So let's do this. Let's say call equals, and we've got our worksheets called lists dot cells. And what I'm going to do is I want to look at the very last cell way over here, the very end of my worksheet. And I want to just do like a control left arrow until I bump into some data there. And so I'm going to say columns dot count. That'll give me however many columns there are in the worksheet, 16,000 some odd, and row number 1. So this is referring to the very last column in row number 1. And from there, I want to call the end method, and I will tell it I want to move to the left. There's a constant that tells it move to left, and it is XL to left. And then that'll give me whatever cell it bumped into as it moved to the left. And now I'm going to ask for the column of that. And that'll be the one that it bumps to that has data. And so I want to add one onto that. That will be the column that I want to put this value in. Pretty good. Then if found cell is nothing, then figure out what that column is. And I want to put the name there. So I'm going to say that worksheet that we're dealing with dot cells, row number 1, column number call, dot value is equal to department. Oh, I probably better match the case. With a little bit of work, we could tell find to match case or not match case. I'd have to record it and see what the arguments are, unless it shows up here. Yeah, so that would take a little bit of work. So I'm just going to make sure I've got the case matching up correctly. Okay, so if I don't find the word department, I'm going to pick a column and then put the word department in it. And my column then is referring to that particular column. Otherwise, if it did find it, I want to set column equal to the column of the cell where it found it. So now by the time I get past this if statement, then column is pointing at the right column that I need to write these values to. That's what I was trying to accomplish so far. So now it's going to say, hey, if the sheet doesn't exist, create it. And then let's go ahead and put the name on there. And that'll be enough for this example for right now. So if the sheet does exist and I run this, it should put departments there. If the sheet doesn't exist, we'll delete this. Yeah, I want to delete it. If the sheet doesn't exist, it'll create the sheet and put it there. If it does exist, I mean, if the sheet exists and the column exists, when I hit play, it should just say, great, it's already there, and my column is set to the same thing. Yeah, column is 2. So it either finds it or it creates it. So it doesn't matter if the sheet exists or if the column exists, it's going to make the sheet and the column exist. Wow, this is great code. I love this stuff. But the whole purpose here was to examine what a error trap looks like. So this was one approach, just get rid of the error. And the truth is, this is probably the right way to solve this one, but it's a pretty simple way to think about an error trap. So let's see what it takes to build an error trap to say, all right, we're going to execute this code, and if it fails, then we're going to do something. All right, so here's what I'm going to do. I'm no longer going to check. I'm going to comment this part out. And now this line right here will fail if the sheet doesn't exist. So you're trying to go to worksheet number list, and there's no list sheet. And so if I get rid of my list sheet and run this part now is going to cause a runtime error. Go ahead and run it. Subscript out of range, there's the error. All right, so here now is the idea of an error trap. The error trap is going to say, let the error happen, but tell the interpreter ahead of time, listen, this next line I'm about to run is suspect. It might fail. And if it does fail, don't give up. Stick with me, don't give up. I'll give you something different to do, because I got to tell you, folks, this interpreter has been around since 1995. How old were you in 1995? Were any of you born in 1995? I'm the only one who was alive in 1995. Can you imagine, like, for your whole life, like you had nothing to do? That's the VBA interpreter. It has been in every copy of Excel since 1995. And the vast majority of instances of Excel, it has never, ever been used. Like every day when Excel opens, the interpreter goes, oh, maybe today's the day my user will use me. And like the whole day, the person's working. And at the end of the day, they close Excel, and what does the interpreter do? Not today. Maybe tomorrow. That's the life of the VBA interpreter. And so listen, it's like it's totally happy to do anything that we tell it to do. It wants to do it. Listen, if we try to do something that it can't do, like it'll be upset, but we'll tell, listen, I'll give you something different to do. Great. If something doesn't work, tell me something different to do, and it will do it. And so that's what we have to do. We have to say, listen, if you try to do something that fails, I'll give you something different to do, and it will be happy. So here's how I do it. I'm going to build an error trap right around this line that is suspect. I'm going to come here. I'm going to say, all right. Here's how I say it. I say on error. This is me saying, hey, listen, after this line of code runs, if there's an error, I'll give you some options as to what you can do. Okay, so on error, and the book talks about on error go to. And so I'm going to leave that in the book. The book has a pretty good discussion of it. It's one that I don't use very often at all, but this one I use all the time. We say on error resume next. RESUME next. This says, if you encounter a runtime error, skip it and move on. It's a really dangerous thing to do in general. What we're saying, listen, if after this line executes, on error resume next, after this executes, we're saying, hey, you get an error somewhere, must not have been important anyway. Ignore the error and just keep on going. It's like a crazy thing to do. In fact, if I was to put this at the top of my program, I've just gotten rid of every runtime error. Every runtime error is gone. I've solved my runtime error problem. I've converted a runtime error, which is easy to find, into what? A logic error, which is much more difficult to find. But just, oh yeah, just the code, the interpreter's like, yeah, great, everything works great now. but it won't be doing what I want it to do. So I'm going to use this. I'm going to localize it just around the code that I think is suspect. So right afterwards, I'm going to come here and I'm going to say, all right, this is the one line that I think might be a problem. So right after that line, I'm going to say if ERR dot number. Now, ERR is an object that has information about when a runtime error happens. In fact, when you have a runtime error and it shows you error number 9, subscript out of range, whatever it is, then that's the number is 9 and the description is subscript out of range. Well, I have access to those things. Like what this has now suppressed the error from being displayed, but I can still look at the error object and see what it would have displayed if I allow it to display it. So I'm going to say if error is different from 0. Error number of 0 means there is no error. Any other error number means an error has happened. Then I'm going to do something. And that is the end of my error trap. On error, go to 0. This is a really strange syntax. And I'll give you kind of the history on it here in just a second. What this line says is revert to normal error handling. Okay, this one up here says, hey, if you get an error, just move on. Skip that line and move on. This one says, all right, after this line, if you get an error, behave your normal way. In other words, halt the code, make a line yellow, put up a message box that says, here's the problem. So on error, go to 0. Whew. In the early days of the basic language, we used to use this statement go to all the time. And what you would do, this is weird, like you would have to number your lines. You're writing a line of code, you would say, this is line number 1. You would write a 1, and you would put what you want line number 1 to be. The next line, you would say, this is line number 2, and you would write the line. Line number 3, you would write the line. Or you could do line number 1, write the line number 10, 20, 30. They didn't have to be sequential, which was good because if you wanted to put a line between line 1 and 2, there's no line 1.5. You'd have to change line 2 to be line 3, and everything else would have to go down. In fact, they had whole programs for like renumbering your programs for you. They say, I want to renumber my program. You'd give it the file, and it would go through and change the numbers to give you some more space between your line numbers to do it. The very first legal line number in BASIC is line number 1. And so when you tell it to go to line number 0, you are telling it to do an impossible thing. And so it's like we're now saying this is something you can't do, and it kind of puts you back into that mode of displaying the error to the user. It's a really weird way to say it. I get that. And I don't know why they chose to do it this way. They could have come up with other things, but this is how you do it. So that line, on error, go to 0, says, if you have an error after this, stop the code, display it to the user. All right. So now I'm saying, listen, but if there was an error, and in fact, I may actually look to see if it's the error I'm anticipating. So let me just, I forgot what error we're anticipating. If I run, I'm still in break mode, so I should be able to get it here. Yeah, it's error number 9. So let's do this. I'm going to go ahead and hit end here. Instead of if error number is different than 0, that means there's any old error. Let's do this. If error number equals 9. Like that means the sheet doesn't exist. Like I totally know what's going on at this point. I know the sheet doesn't exist. So I'm going to make it. Great. Well, I already have a line of code that does it from my other way of handling this problem. So I'm just going to copy it and put it up right here. So if the error is number 9, then we'll make the worksheet. Now, there's just a little bit of a risk here that I have to decide if I really want to do this, because at this point, here's the line that I thought might trigger the error. And at this point, I am right here in on error resume next. So this could potentially also trigger an error. And in the state that I'm in right now, it would just skip it and move on. So even though me writing the code, I probably wouldn't do this, but it's probably safest to say, like right here inside this, to say, you know what, turn off my error trap because I have already trapped what I thought might happen. And if this next line does a problem, I want to know about it. So that looks pretty good. And the only problem is, what happens if I have an error other than number 9? I don't know what other error I could have besides error number 9. But let me just do this. If the error is 9, I'll do that. It's not 9, but it's not 0. So I'll do an else if. If the error number is different from 0, then what do we want to do? I think we want to just make that error happen. I'll turn this off again, turn off my error handler again here. This is not the prettiest code in the world. And I'll say err.raise. So I suppressed the error here. I'm checking to see if there was error number 9. If there was, I know what to do. If there was another error other than 0, I don't know what's going on here. I just better show the error message up again. And I think that will do it. So let me change this to do error number 19, which it won't be. And that should raise the error. Let me just make sure I've got that code right. No, error. So I got to give it the error that I want to do. And so this will be the number that I want to raise. Error.number. There we go. Okay, so now stop. On error, yeah. Did that raise it? Let me just try one more time. You know what? Let's just ignore this part. That's not doing what I thought I did, and it's making this more complex than I want to do it. So it's still going to come through here and try to, let's see, go products. It'll have another error that comes along, and we'll let that one handle it. Is that right? On error, resume next. Oh, here I'm just printing the row. I think I actually wanted this to be higher. That's all right. We'll print the row, we'll have that error, we'll fix it, and we'll move on. Okay, so now let's look for number 19. This now should take care of the problem. Stop this, I'll run it. Tells me subscript out of range. I better put a break mode and go step by step through here. Let me put a stop in here. And run it again. Okay, so I'm going to step, this is actually part of what we're learning today anyway, is that I can go one line at a time here by pressing F8 or coming to my debug menu and doing step into. Here's where I'm expecting this. I can see where it goes. What is my error number? I thought it was 9. Error number is 0. Because I just printed that, and this was the line that I expected to have here. Okay, so this is the line that I'm expecting to have the problem. So that should throw the problem. So it's the set found cell is the one that I expect to find. Okay, so now it's coming into the error trap. It's going to add that sheet. But I need to run this line again. Now that it exists, I need to run that line again. So I'll bring that down here and run it again here. So now that should bind the found cell on to it. So yeah. Found cell. Okay, let's go through it again right here. So we're saying, hey, if there is an error, resume next. And I'm trying to bind the found cell onto that cell. This is going to throw an error if the sheet doesn't exist. And it's going to throw error number 9. So when it throws that error number 9, this will be true. We are going to add that worksheet. And we don't really need to find it. We know it's not going to be there because we just barely created it. So, but I'm just telling you the same thing again, and that will set found cell to nothing so that when it gets down here, it looks at it. You could probably clean this up and have it behave a little bit differently, but this shows the error trap. So the runtime error happens, I notice that it happened, and then I decide what to do with the code. The tricky thing to remember is to shut your error trap off, to end the error trap so that you don't inadvertently miss other runtime errors that come in the future. Questions here on the error trap? Okay. So now, why don't we go ahead and finish off this example and have it actually do something here, and then we'll look at like stepping through code. So at this point, we know that we've got the sheet, we know we've got the column set. It's just a matter of checking to see if the value that we're currently examining is in this column. So we'll just do another, we'll just set our found cell range equal to the list worksheet dot columns, column number call dot find. So we're now looking on that worksheet in that column, whichever column we found, and we are looking for the value that that I deleted that we were printing. So we're looking for the value back on our products sheet. So what are we looking for? Products. There's actually the worksheet has a code name, and it's products dot cells row number row, and our lists are in product or in column number 3. I mean, our department is in column number 3. So we're looking at column number 3. And we're looking for an exact match, Excel hold. So if it has found it, it already exists, nothing else to do. But if it hasn't found it, then we need to add it to that column. So if found cell is nothing, then we have to add. Whew. So, and we just have to add that onto the bottom of the list. So we're going to say on that sheet, cells, what row do we want? Let's go to the very bottom of the sheet, rows.count, column number call, end, XL up, offset. That's going to be the one that has the data. I want to go one below it. Offset 1 row, 0 columns. Value is equal to the value of the row that we're looking on in the 3rd column. Ooh. So we're going to look in that 3rd column to see if we can find the value that we're currently looking at here. If we do find it, there's nothing to do. But if we don't find it, found cell will be nothing. Then we're going to write to that worksheet, column 3, go to the bottom, come up until we find some data. But don't, if we're right there, it'll write over the top of it. We need to come down 1, so we'll offset 1. We'll set its value to that. Ooh. So if I run this code now and let it run through, where do I stop? It should fill in all the different departments on that sheet. Look at my list sheet, and there's the 4 items: hunting, outdoor, general, and apparel. Okay. So at least we got the example working now. Let's look at the other debugging tools that we have at our disposal. You ready to do it? Let's do it. Okay, so far, the main tool I've given you is to create a breakpoint in code by typing the word stop. There's another way to make a breakpoint. Let's say I want to kind of watch what's happening with this code. I can click right here in the gray margin and turn that line red. Presumably, it's happened for most of you that you have clicked there by accident. You clicked there, and that line turned red, and you went, what have I done? And you're like, oh no. You clicked it again, it went away, and you went, oof. But that's a breakpoint. So if I put that there and I run this code, it's going to take me into break mode right there. It's exactly the same thing as writing stop in the code. And it's going to stop the code before this line executes. Now, the important part here is I'm in break mode, which means that this subprocedure is loaded into memory. All the variables have been declared. And if I put values into them, they've been set. So I should be able to come to my immediate window here and say, let's see what's in row. Wait, row is 0. I thought row equals 2. Why is row 0? Because it stopped before this line executes. So I can execute this line just by pressing F8, execute that line. And now if I evaluate row, it's going to tell me that it's 2. Okay, let me introduce you to another tool in your debug menu, and that is your locals window. Is it here? Oh, it's not the view menu, sorry. View locals window. It's really tough to see here because I know they're tiny on the screen. But what the locals window shows you is it shows you the current value of all of your variables. So here I've got 3 variables in here. I've got row, I've got call, and I've got nothing. And let me zoom in, Windows plus. So row, call, and found cell, the 3 variables I have in this module. And right now, this is 2. The other ones aren't defined. So as I step through this with F8, I'm going one line at a time. I should see those change when they change. So here's set found cell equal to this. Right now, found cell is nothing. I'm going to execute that line. And now found cell is like an object. It's bound onto an object. I should be able to come down here and find the name of it or the address. Found cell. Kind of expected to see the address. Should be able to see the value. There's value 2 is department. That's what I expected. I'm not quite sure I don't see value down here. Anyway, so I can kind of come now and explore all the properties of that object. Now, here in just a second, if we keep going through this, we're going to set, I got to zoom out. We're going to set column equal to something, and you'll see that tiny little 0 there change to whatever column we're after. So keep going through here. Here's where we're going to set the column. And so that should read the column of the found cell, and it does. Brings the 2 in here. So the locals window is really handy because it kind of shows you all of your variables, and as you're going line by line, you can see how they change. So if you're saying, wow, I'm getting the wrong output here, you start to say, all right, what is each one of these lines supposed to do? What do you think it's doing? And when you execute that line, you can see, does it really have the effect on your variables that you're expecting to have? Now, you can see your worksheet, right? You can actually look on your worksheet and see how those change, but variables are just in memory. So this is nice. It gives some visibility to those variables in memory. Questions here? Really similar to the locals window is another thing called the watch window. So let me come here and view the watch window. So the locals window is just saying, listen, you might want to look at your variables. Here's all of your variables. The watch window says, you know what? You can watch any expression you want. It doesn't have to be your variables. Like I could actually look at something in a particular cell, like B4's value. So I could come here and add a watch expression. How do I add a watch expression? I come to debug and I click add watch. And so I can just put any VBA expression here that I want to be able to evaluate, and it will evaluate it. So I could say, I want to see what's in range A2. or range B3, range B3 dot value. And that'll be a watch expression. I'll say okay. And it's now added that in. So similar to the locals window, it's now showing me the value. When it changes, I'll see it change straight away, but it's this expression. I get these more complex expressions rather than just variables. And they can be pretty long, complex expressions. So you can kind of look at that and say, yeah, I want to know, we'll know what that value is. So that's helpful for giving visibility to what's often difficult to see, is have these watch expressions. Now let's do this. I'm going to say, I don't think apparel should ever be showing up in here. Like, let's suppose that I didn't expect apparel to show up and apparel is showing up. I'd like to know when apparel shows up. In fact, if I know that it shows up in B5, let me do this. Let me put another watch expression in here. Debug watch, add watch. And I'm going to say range B5 dot value equals apparel. How do you spell apparel? A-P-P-A-R-E-L. I don't know. I'm going to add that watch, then I'll go back and fix it if I have to. A-P-P-A-R-E-L. Okay, it looks like I spelled it right. Okay, so this, let me edit this watch expression. All right, so I'm A-P-P-A-R-E-L. All right, now this is a watch expression. This will be true or false. But here's an interesting thing, is that I can say, you know what, make this into a conditional breakpoint. Take me into break mode when this condition becomes true. So one way to set a breakpoint is say, before you execute this line, take me into break mode. This kind of breakpoint that I set up in a watch expression says, when this condition becomes true, take me into break mode. As soon as the value of B5 equals apparel, take me into break mode. I'd like to see where I am when that happens. So now I'm going to go ahead and just run my code out again. And it looks like B5 never equaled apparel. B5 looks like it equals apparel. Make sure I've got that right. Edit this. Okay. That's, I think, what I had before. When that becomes true, it should break. So what I'm going to do here is I'm going to put a stop down here at the very end of my code. And I think I've got a breakpoint. I'm going to go ahead and run my code, hit that breakpoint. Right now it's true. Let me go ahead and make it so it's not true. And we'll step, on my active sheet, go ahead and step and see if that changes. Yeah, okay, so it's changed to false. And that should go to true. Let me go ahead and just run it again from here, F5. I'm not sure why I missed it the first time, but now you can see that it's changed to true here. And it's taking me into break mode. Now it's right after the line that happened. So if found cell is nothing, which it was, it came here and it plugged in that value, put apparel in there. And that is what allowed it to come into break mode. So it says, wow, that condition just became true. Stop, right here's where you are in your code, where that condition became true. So the conditional breakpoint can be really handy. You build an expression that says, here's something I don't think should ever happen. And when it does happen, stop my code so I can see where am I that made this thing happen. So that conditional breakpoint is like one of the most powerful tools you have for kind of tracking something down, especially when you're doing iterative code. You can't go step by step through it all because it'll take forever to go step by step. Okay, so that gives us the watch window. It gives us the locals window. It gives us the conditional breakpoint. You go ahead and edit this one again. And just realize you can, we've set, and this is the way I almost always use it, is to set it to break when the value is true. So I set this thing up like so that it will change to true when I want it to stop. Or you can say, hey, anytime this expression changes, take me into break mode. So this expression here, might be changing several different times. I can say, hey, every time it changes, take me into break mode. So that's the other thing there. So being able to step through line at a time. Oh, let's talk about stepping. So in my debug window, I've got like 3 different steps here. And so to do this one, I'm going to go ahead and I'm going to stop my code here, and I'm going to re-enable this call to my not exists here. So here's where I'm preventing the error from happening rather than trapping it. So I'm going to re-enable that code. And I'm going to run where we are. So we'll go ahead and hit F5 to run, and I'll step. So F8, step, 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 step. Okay, now what I'm about to do here is I'm going to say, hey, I want to do not exists. If the sheet doesn't exist, well, it's got to go and run this function to find out if it exists. It's got to return true or false. If I press F8, which is step into, this is where the into comes into play. Step into says, listen, if you are calling a sub procedure that you've written in VBA and you're stepping into, you want to step into that sub procedure. You want to go through that sub procedure. So when I press F8, it's going to be like, yeah, let's go down into that sub procedure and we will step through this code. Now, quite often you're saying, I know the problem is not in sheet exists. So if I accidentally came in here, just get me out of here. Well, that's your third stepping. So I can come back to my debug. The third step is step out. That says, just get me out of here. So when I do Control-Shift F8, it says, finish running this sub procedure and take me back to where it was called from. I'll do step out. That there's no way to say, stop where you are and take me back. Step out will say, finish this one off, and then go back up to where you called from. That's right. Like after it ran this, here's the next line that I would hit. And I can drag back to there and do it again. That's one of the great things. Like, I don't know of any other debugging environment that lets you do that. That is awesome. To be able to say, you know what, just go back to here and do something different. I'm going to drag back to there. And now I'm going to do the third kind of stepping. And that's step over. Now, you would think that step over is, don't do this line. Like if you're walking down the street and you see something on the sidewalk that you do not want to step into, and you decide to step over it, you've like bypassed it altogether. But that's not the case here. Step over means run that without stepping. So in other words, don't go into it. So if I do step over, Shift F8 or debug step over, it's going to run that sheet exists function, but it's going to do it without stepping through it. And so for me, when I'm debugging, it's like set a breakpoint and then Shift F8 is what I always want to do. I always want to step over unless I'm going, oh wait, yeah, I do want to go into that one. And so like for me, the default is step over, step over, step over, step over. Oh, this one I do want to go and look at it, step into. And then step out. If you accidentally get into someplace you didn't want to be, you can step out of it, finish running it off and bring it back. So that is the step in, over, and out. This one, I mean, this is pretty self-explanatory. You can make a temporary breakpoint with your cursor, right? I'm going to put my insertion point there, and I can say just run to there. So I didn't actually set the breakpoint. It's like let my cursor be the breakpoint for now. And then one of the other things that can be kind of handy here is that if you are like, you know what, I'm in some other sub procedure, and I know I'm in break mode because it says break mode right here, but I forgot out of all the modules I have open, I forgot where I am. Well, your debug can say, show the next statement. And that will take you to there. Remember that you can drag to set your next statement somewhere else, but you can also put your insertion point on one line and you can say debug set next statement, and that will be the same as dragging it there. That's limited to inside the sub procedure that you're on. You can't say, oh, I'm going to set the next statement to some other sub procedure. It wouldn't have the context to do that. But within a sub procedure, you can say, just bounce back to somewhere else. Folks, those are the main tools for debugging. What else do we see? Toggle a breakpoint. There's a keystroke for turning a breakpoint on and off. Oh, clear all breakpoints. I never used it. There's clear all breakpoints. Yeah, that's it. Questions on debugging? The other thing you see in the schedule for today is the study guide for the midterm exam. This concludes the instruction for what will be on the midterm exam. I'm hoping that the midterm exam doesn't open until next Tuesday because the exam is not there yet. Do I say when it opens in Learning Suite? When does it? It's next Tuesday. Okay, yeah. So sometime before the end of the week, I got to get the exam over there so it'll be available for you. And I think it's available all of next week. That's probably worth us talking about real quick in the minute that we have left. Learning Suite. Sign in. Because the test is in the testing center. You are allowed to take scratch paper. I even think I said you're allowed to use a calculator, but I don't know that you really need one. There'll be some math that you want to do by hand, but it'll be really simple math. We have 1 minute. Probably should have spent a little more time on this. I got to approve this. Hey, let me approve. Okay, I can't approve. So just a couple quick notes on the exam. The last day that the exam is there is a late day. You will pay $5 for the privilege of taking the exam. You want to procrastinate one more day before studying, it'll cost you $5 on that last day. And then the other thing is the study guide shows you the kinds of questions that are on it. So what I did in making that study guide, I went through everything that we've done so far. I looked at the book and said, these are the sections I want you to be familiar with. Like I built the study guide first, and then I built the exam. I went to the study guide and said, all right, how do I test that point? How do I test that point? How do I test that point? Oh, that point's too hard to test. I'm going to skip it. How do I do this point? And so that study guide should be a really good preparation for the exam. It'll show you the content I need you to know. All right. Thanks for coming, folks. I will see you next Tuesday. Class dismissed.